Hello, today's lesson is 5.5's first day about completing the square, why it's important dealing with the vertex form. So the essential question today is, how is completing the square helpful for vertex form? What is vertex form? Hopefully we can answer that question too before we leave. So the perfect square trinomial is a trinomial of the form where you've got an x squared term, or you should have some sort of squared term before. Like this could have a sort of leading coefficient that's not just a 1. It could be a 1, 4, 9, any sort of perfect square. And then you've got some sort of term, but this last term takes that middle term, divides it in half, and then squares it. So this actually factors into, hold on one moment. So this actually factors into x plus whatever that middle term divided by 2 is, squared. So let's see if we're going to write the expression as a square of the binomial. So really we're going to complete the square. My bad. We're not completing the square. We're just going to write the expression as the square of a binomial. So basically we're factoring. We're going to write the factors as a perfect square. So instead of saying x plus b over 2 times the quantity x plus b over 2, we'll write it as a perfect square. So first example, we have x squared plus 8x plus 16. Let's make sure that it's a perfect square. So if you took 8 divided by 2 and then squared it, would you get 16? And we would. So this is going to be 8 plus whatever that quantity of 8 over 2 is, which is 4, squared. So there's the perfect squared binomial. Then we have to figure out, is this a perfect square? If we actually factored this, so it's not as cut and dry as the previous example. But let's see, if we were to figure out, okay, what multiplies to 4 but adds to negative 4, could we have the same thing written in both parentheses? So what multiplies to 4 and adds to negative 4 is negative 2 and negative 2. So let's see, if you took the square roots of each of these numbers and put them in the front, and the square root of that constant and put it in the back, and wait a second, we need to add to a negative 4, so both of those signs need to be negative, we actually do get a perfect square. We just have to write it as 2x minus 1 quantity squared. That one was more of a challenge. We'll be dealing with more square binomials looking like this. So before we can actually see why completing the square is important in dealing with quadratics, let's just deal with the method first. So let's say we have an x squared term and then some sort of x term. There's going to be some value that's going to complete that square to where we can put it in, we can put its factor in parentheses to the second power. So we want this to make a perfect square. That's the goal. So now we're going to see where that formula up in the top of our guided notes really comes into play. We're going to take that middle term, divide it in 2, and then square it. That's what our c is going to be. So wait, this becomes negative 6 squared. So negative 6, and then if you square it, you're at 36. So that c is going to be 36. After you find that completed square, now let's actually see what the trinomial factors into. So what multiplies to 36 adds to negative 12. So that'll be x minus 6, which we will write as x minus 6 squared. Notice how the number of that b value, or that middle term divided by 2, is what goes in parentheses. All right, so let's practice again. In the next term, we're still going to have to figure out, all right, we got to take that middle number, or that linear term, divide it by 2, and then we have to square it. So wait a second. This isn't perfect. So what do you do if it's not perfect? You still square it. You get, well, you're going to square the numerator. So C is going to be the square of the numerator over the square of the denominator. That's what we're looking at. Sometimes it's okay to get fractions, and we got to be aware you still follow the same rule. So if I wanted to write the expression of the perfect square trinomial, this is going to be the quantity x plus that 5 over 2 squared. Completing the square will be helpful for this vertex form that we're going to be learning about. So let's turn the page to your next side of notes. So first off, vertex form of a quadratic function. When we learned about lines, we had slope-intercept form, point-slope form. So now that we're going to a new function, there's actually a specific thing called vertex form, where you have some sort of leading coefficient. And we're going to talk about that. There's going to be some sort of factor here sometimes. Most of the time, we're just going to be dealing with a 1 there. And we've got x times the quantity x minus h squared plus k. So this is going to be that perfect square that we're going to need. So where h and k is the vertex of the parabola, the vertex being that either lowest point or that highest point if the parabola is flipped upside down. These numbers are going to be that special point, or that special place in the t-chart where everything starts repeating itself on the y column side. Again, this application will be seen later on. We're just going to be practicing the strategy now, but it's coming up where we're going to have to graph parabolas constantly. So this is where the application is going to be handy for completing the square. So like on the previous page, we're going to have to figure out what's going to complete this square if I want to get it in vertex form. But what I need you to do is put a little space between the quadratic term, the linear term, or the x squared term, the x term, and then the constant term needs to be a little bit further away because we want to put some room in here for the c value. Or wait a second, hold on, let me back up. That's not actually what I want you to do. Hold on. I want you to move the constant term to the other side to be with the y. So we're going to have y plus 24 equals x squared plus 2x. That way we can clearly see we're going to find what completes that square. So you're going to take that middle term, or you're going to take that x term, divide it in 2, and then square it. Figure out what that number is. And I'm going to add that number to both sides of that equation. So we realize this is going to be a 1, so I'm going to add 1 to both sides. We have y plus 24. I'm going to add 1. X squared plus 2x. Again, I'm going to add 1. So now on the left side, I have y equals 25. And then on the right side, I have this perfect square now. X plus 1 squared. So to put it in vertex form, I'm going to have x plus 1 squared minus 25. There it is in vertex form. Let's see if we can actually find the value of the vertex. The vertex is going to be opposite of what's inside this x position, but we're going to keep this symbols, or this position sign. So the vertex in this first example is going to be negative 125. Let's move over to the next example. So again, I'm going to subtract 15 to the other side to get x squared and 6x by itself. And I'm going to ask myself, all right, 6 divided by 2, what's going to complete that square? So we've got, let's see, 3 squared is going to be 9. So I'm going to add 9 to both sides. I'm going to get like terms together on the left side and write the completed square on the right side. And notice how in the completed square, it's that middle, or it's that linear term divided by 2. Because this would be x plus 3 times x plus 3. In the vertex form, adding 6 to the other side is y equals the quantity of x plus 3 squared plus 6. So the vertex is going to be opposite of that x position, negative 3, but you keep the k sign. On to the next example. Once again, I'm going to subtract 9 to the other side. I'm going to try to figure out, okay, negative 10 divided by 2, and then square it. And that's the number I'm going to add to both sides. So let's see. Negative 10 divided by 2 is negative 5, but squared, you're having a positive 25 to both sides. We simplify and write the completed square. Get it in vertex form, so we have x minus 5 quantity squared minus 16, and we can easily find that vertex. Vertex is going to be the opposite of this. I kept calling it the x position because it's the x coordinate position of the vertex, but earlier you're also going to, or later on you're going to hear me that it's the h position because that's what that form was at the beginning of notes on this page. So this is positive 5, negative 16. Next. So this one is a challenge. We add 7 to the other side. It's a challenge because we're going to have to, well, we've got, okay, negative 3 divided by 2, but then squared. We're going to be dealing with a fraction. So we've got to think of, all right, negative 3 halves squared. That's going to be a positive 9 over 4. That's what I'm going to add to both sides. Positive 9 fourths. And then I'm just going to write the simplified version of 7 plus 9 fourths in an improper fraction. And same, whenever I write the completed square, it's going to be an improper fraction form. And we've got to recognize that inside those parentheses for the completed square, it's going to be x minus that middle term divided by 2, that position. There's our completed square. So to get it in vertex form, we've got x or y equals the quantity of x minus 3 halves squared minus 37 fourths. So this crazy vertex would be positive 3 halves, negative 37 fourths. So homework for this entire section. I realize there, like on your, my bad, on second hour's guided notes, you have no homework assignment. So just for second hour, section 5.5 is going to be a combination of these two. You're only going to be able to do 73, 74, and 79 over the weekend. And actually, I did not mean 79. I mean 75. So anyway, your homework is going to be 73, 74, 75, basically tonight. So at the end of class on Monday, you should be able to do 55, 56, 59. So if you want to get a head start, that's where we're at, but you won't be able to do all of it. All right, have a good weekend.